Hey, welcome back to the OT Asset Management Weekly webcast. Today's topic is data flow, OT data flow collection and analysis. A rather interesting topic because it gets us deep into threat detection space and also sophisticated protective strategies that you can extract from that. But first, we need to make it clear what OT data flow really means, and you will be surprised. No, it's a loaded term. So I think what most of you will already know is these diagrams from OT threat detection products, or they usually call it network graph. Actually, it's not a network graph because an OT threat detection product doesn't know about networks. This is a data flow graph, and then you could make all kinds of funny animations happening. You may have seen that before with those threat detection products. I think it may have some entertainment value, but it really doesn't add anything to the functionality of the product or of the data flow analysis. But the dividing line here is data flow is mostly about metadata. That means who is talking to whom, rather than the content of the data. And data content, as you will certainly know already, is what threat detection solutions focus on. They're doing deep packet inspection in order to analyze the content of the data, in order to tell, somebody has just tried to manipulate that specific process variable on a PLC. And that is beyond data flow. So data flow per se is only about metadata. Who is talking to whom, using which protocols, and when that communication happens. So deep packet inspection goes a bit further and examines the content of that data flow. And that relates to a different threat model, because it suggests that it would really be important to check out the content, since you expect malicious bits and bytes in that content of the data. And that is a rather, I would say, bizarre proposition, because we haven't seen that in the past in actual attacks. So case in point, if you analyze Stuxnet, as certainly I have done, you would not have found any malicious Modbus or S7 writes to PLCs or to RTUs. That didn't happen because the whole controller logic was compromised and everything was being executed on the PLC, talking to the analog devices or talking to the Pro-Fi bus devices, where certainly your OT threat detection solution with the DPI has no visibility in that. So the only example that would come to my mind where you would actually see an attack in progress. So just again, thinking about what we have on the record of OT, real cyber-physical attacks on the record. The one example that would come to mind is the Ukraine attack in 2015. And if you want to have an update on that, or just a frame of what did happen, just the most important facts, I urge you to check out this video here. It's called "The Most Important Lesson from the Ukraine Cyber Attack," in our YouTube channel, in the playlist The Red Pill Series. Okay, and there you find this video on the Ukraine cyber attack, where I talk you through the various stages of the attack, what the attackers did. And in that particular example, you would have been able to trace the attack using the packet inspection. And problem is, that wouldn't have helped the poor Ukrainians, because the operators at the time were aware of the attack unfolding, but they had no means to stop it anyway. And so therefore, I would probably just use the utility of deep packet inspection with a grain of salt when it comes to your overall protective or your overall OT security strategy. So you know what we suggest? We call that performance-based OT security, where we produce 80% of the results with 20% of the effort. And how do we do that? Our today's topic is a good case in point, because I will show you how you can gain a lot of utility by simply ignoring all that content in the packets. You don't need that in order to arrive at a substantially better security posture. So if you just focus on data flow, meaning on the metadata, that goes a long way. I will show you how, but before I do that, I also want to point out another video in that Red Pill series of our videos on our YouTube channel, and it's called Deep Packet Inspection is Obsolete. Here is why, and you can already guess, that relates to our topic. Probably you can just do without deep packet inspection and still gain a lot of utility for improving your protective approach. And in that video, I'm also going to show you an interview with or a discussion with the former head of the NSA, the National Security Agency in the US, General Michael Hayden, where he is absolutely clear on this. So the NSA has abandoned deep packet inspection when they intercept phone talks, for example. No, they don't listen to what they actually talk on the phone. They are interested in who is talking to whom at which point in time. And certainly for our purposes, you would also add the protocol that is used, okay? So in my opinion, very interesting snippets in there, very interesting clips from former director of the NSA, General Michael Hayden. You will like what you see. Or let me rephrase. So it's going to provoke thought, and hopefully also going to provoke discussion, which is what we definitely need in OT security, because that whole field has become so sterile. It's just unbelievable. Everybody is talking, the threat actors and the threat intelligence and the this and the that, but we see very little innovations when it comes to the question, how do I better protect against potential cyber-physical attacks? So let's get back to the big picture. Deep packet inspection implicitly comes with a certain threat model. And that threat model would be, you have to consider sophisticated attackers that will manipulate your physical process by writing legitimate commands to your actuators, to your peripherals. And I don't think that's a very valid proposition. I think that it's much more valuable to just strip off all the content and only focus on the metadata. And this is what we do with the OTbase OT asset management system, and we'll get to there in the details in just a minute or two. I just want to frame our threat model, if you will, or maybe to put it another way around. What we are interested in with OTbase is to raise your protective posture, to reduce your attack surface, raise your protective posture. And by analyzing the data flow, you can understand potential infiltration paths. That's the important thing. You can understand where traffic occurs that you don't like to see, potentially from illegitimate endpoints. And that's a very important observation here. If you would see, just as an example, there is a computer on the enterprise network and it talks directly to one of our PLCs, that is not something that you want to see, regardless of the actual packet content. That's the important thing. You don't need to examine the content of the communication. You just need to state, well, this is not an allowed communication path. No system on the enterprise network should be able to talk directly to a PLC. And I tell you how you can actually visualize that in OTbase. The other benefit that you get from data flow analysis is that you can certainly and should use it for your network segregation efforts. So before you define any new firewall rules, you must certainly have a clear understanding of who is communicating to whom, regardless of the content of the communication. So we're interested in the network location of those endpoints that talk to each other, and certainly also the various protocols that they use, etc. So let's see how we make that happen in OTbase. We are starting with the device inventory that you have seen a couple of times. So every row in this table represents one device. And when you drill down and open what we call a device profile for any of these devices, you may find a section in the device profile that is called data flow. And in that section, you will see the data flow for this device. And you will notice a couple of things. First of all, you can move this around without that silly animation. Your arms start to move around separately, individually. So we don't actually go that far into silly space. But you can examine everything very closely. One thing I would like to point out is once that you hover over any of those arms, then you will see the actual protocols that have been used in that path. And the thicker the arm is, that tells you a little bit about the amount, the number of interactions or the number of protocols that have been observed. Another, in my opinion, extremely interesting feature here is that we expose different categories of data flow. And you also see that up here in the Sankey diagram. So you see red, blue, and gray. What does that mean? Well, red is, well, this guy is talking to the public internet. And certainly we want to highlight that fact. We want to expose it. And we are using the color red for it. So what we can certainly see here is a lot of web traffic from this station. This is not something that anybody wants to see in an OT network. Certainly not from an engineering station, as in this case. And then we have the color blue. Blue tells, so it suggests, no, everything's fine and dandy. So that's okay. That's traffic that occurs within the local subnet. So well, from a security perspective, not a lot to worry about. And then finally, we have gray. Gray is traffic that goes into other private networks. And that is something that you may want to research, or if that is coherent with your security policy, if you will, or if something needs to be done about that. So it certainly tells you, well, there is some routing going on here. And we also expose the endpoints, or we simply tell you it's going into that other network that you're going to see. And maybe that's one of the most important takeaways here. OT threat detection solutions usually don't know anything about network association. And that's bad, because what you would like to know is, well, is this traffic that occurs in one and the same subnet, or does it involve any kind of routing, or even goes to the public internet? And this is something that we show here by categorizing the addresses that we have collected. And then if this exposure is public, you will also see that flagged right here in the entry section called General, where we already tell you, well, this system has public exposure to the internet. By the way, it's also critical for engineering, so maybe you want to do something about that. And this is how you can extract extremely valuable data points from the data flow that was observed without any need to go into packet content. So what does it give you as an example? When you would see in a threat detection solution, oh, there's malformed traffic there. So what do I need to care about malformed traffic if I miss, for example, the fact that this system is talking to the internet, that it routes into all kinds of other networks? So let's start with the basics first. You have been focusing on potentially extremely sophisticated threat models, where the attackers would actually manipulate specific process variables at the worst point in time. Those OT security vendors usually try to dramatize everything, and the criticality is for them is very important to suggest relevance. But for practical matters, it makes much more sense to start with more mundane, more humble things like, well, what is the exposure level here? No, it's the same subnet, or maybe another private network, or even the internet. And this is what we show you here in those diagrams that are not animated in those funny ways. And the other thing that I believe is extremely useful, in those diagrams, you also have drill down capability. So when you want to see, for example, when you want to examine this interaction here, I want to know who is this guy. Well, I just need to double click on that box, and then I get the device profile for this other box, so for this other system, certainly also with the data flow, etc. And then a picture starts to form in your head, right? So you understand the interactions. And this also now explains to everybody why we are using these pop-up browser windows. Well, because this allows you to view device profiles, network profiles side by side in order to get a better idea of these complex relationships that might exist. Okay, and since we are there, I just want to point out those color codings for the devices. So within those boxes, they relate to device types. So, for example, anything IT related, anything computer related is color coded in blue by default. You can change the colors if you don't like blue, for example. You can change it to red or to green. And by default, everything related to controllers is color coded in pink. So there we have a printer that's color coded in green, but you can change those color codes if you don't like them, just saying. So another thing that you can do here, also extremely useful, we can extend this diagramming to a full network. So in the connection section, we see all the networks that this endpoint is residing on. And if we do a drill down here to that office network, guess what? We can also see the data flow for that whole network. And certainly that is a bit more complex. And that's a great way to really understand what's going on in your networks. It's a great way to identify possibilities for tightening your security architecture. And to reduce your attack surface. And you can go down to much more detail. For example, in that data flow section here, we not only have the cool diagrams, we also have tables that show you the interactions that took place with all the IP addresses, okay? Again, divided by local, private, and public. So you could even see where is this guy surfing to, because the IP addresses are exposed. So this gives you an idea of all the interesting things that you can do by looking at data flow. And again, I think a very important point when you consider strategy and your overall security approach is don't overcomplicate things. If you really want to analyze those alerts, somebody has changed that specific process variable, how long is that going to take you? So that's something that an analyst might spend a couple of hours on, if not days. And then he or she needs to talk to an engineer, control engineer. Is that actually a legitimate interaction or is it not? Let me tell you, you are just wasting an enormous amount of time. Start with the basics. Start with checking if those interactions per se are legitimate or not. Is what you're seeing, is that what you want to see? I can promise you one thing, it's certainly not what you have expected. So everybody, especially control engineers, they have their idea of who should be talking to whom and when. And when you see reality, you are in for a surprise. Last, we want to look at how OTbase actually collects the data flow. And maybe the most important thing to start with is, well, we don't use hardware sensors. Guess what? Isn't that convenient? So you don't need to stuff your networks with hardware sensors that you plug into the span ports of your switches, because that is just overkill. For data flow analysis or collection and analysis, you don't need that. You don't need hardware sensors because you're not picking up all the traffic in real time and inspecting the content, etc. You don't need all that hardware horsepower. We only rely on software. And for that software, we have a couple of alternatives, which you can see here. So all the different sources that we use for collecting data flow. So let's walk through this from left to right. The first option would be your standard OT-based discovery software. It does include to collect traffic from your switches if those switches use the NetFlow protocol or the NetFlow service, if you want, okay? And your network guys will be able to tell you right away, no, they don't support that, or they say, oh, certainly. And then they need to reconfigure the switch so that the switch sends the NetFlow traffic to that endpoint where OT-based discovery resides. And that's all that's needed. So, and then that data is picked up and automatically pushed to OT-based inventory. Second alternative is, again, OT-based discovery, the regular product, but your switches don't support NetFlow, but they do support S-Flow. That's just another technical protocol that yields the same data. Third option, there is a discovery agent for specific scenarios where somebody says, no, we don't want to allow or we can't allow OT-based discovery to remotely connect to our Windows box and discover the software configuration via WinRM. We don't want to do that. Then you can install an agent version on that machine. So you can leave your WinRM port closed. You don't need to provide those credentials. And then the software configuration discovery is done locally. And here is the kicker. That agent will also on the side collect all the data flow for this specific endpoint. So that just comes as an added benefit. You don't need to configure anything. All that data flow is collected automatically and then sent to OT-based inventory. And finally, If you want to, you can also use that agent. And by the way, that is available for Windows, for Linux, for Docker, for everything. You put it on a Raspberry Pi if you have to. You can then also connect that agent to a span port, and then it will just collect that traffic from whatever sources are on, or whatever you provide on that span port. Will bundle everything and send it to OTbase inventory. So you got a lot of options, and all of these options are software only. You don't need to deploy dedicated hardware. You don't need to invest in expensive hardware sensor products. So that gives you an idea how OTbase handles data flow and what you can and should do with data flow as compared to the packet inspection. We do have a couple of questions from one guy, Cristobal. I applaud the effort. So actually, this is not a question. This I would read that as an affirmation. Data flows are indeed the most important info to identify and analyze. Yes. Once again, I urge you to check out that video. Let me go back there on our YouTube channel. I urge you to check out this video. Deep packet inspection is obsolete. Here is why. You will love the quotes from the spy master of the universe, General Michael Hayden, who tells you in direct language, oh, the NSA only looks at metadata. they no longer digest the content. And that's from a couple of years ago. So that is a very compelling argument that he makes. And also it's entertaining to watch. Thanks for the affirmation. And wait a second, we have another anonymous LinkedIn user. Do you get NetFlow from every switch in the network or only core distribution? No, you don't. You only get NetFlow from those switches that actually support NetFlow. And so that's not 100%. First of all, you would expect to find the NetFlow protocol or service on Cisco layer 3 switches. For lower level switches, let's just say layer 2, I think, for example, the industrial Ethernet switches from Cisco, they don't support NetFlow. So that is not an option that is widely available, but where you have it, you can take advantage of that. What else do we have here in the comments or in the questions? Another one from my guy, Cristobal. This sort of functionality is promoted as intrusion detection system and is indeed a waste of money, time, network configuration, etc. I just take your word. Certainly, I think our friend Cristobal has a point here, because let me again emphasize the angle where I'm coming from. I want to see efficiency. I want to see performance-based OT security. And this is what we haven't seen over the last couple of years. We have seen fear, uncertainty, and doubt, where everybody's talking about risks and criticality, but that only moved the needle so much. I want to see real significant progress in OT security, and that would suggest to experiment with alternative approaches that require much less effort, yet yield significant results. And that's probably the major reason why I'm interested in data flow analysis and why we chose to implement it in OTbase this way. And for example, just being able to get rid of all the hardware sensors. No, we don't want that, because we're targeting very large enterprises with hundreds of networks, and well, then you don't want to deploy all those hardware sensors. The other area is, and this is where Cristobal points to, intrusion detection. Well, what you're seeing there, let's be honest, that's 99.999% false positive alerts. They are not real intrusions. They are not the Iranian hackers or the Chinese, the Russian hackers. Just insert your threat actor of choice, the kryptonite and the kryptonite. No, that's not what you see. What you really should be worried about, talking about threat models once more, is ransomware, guys. And then on top of that is to make sure that either by malicious action or just randomly somebody from, let's just say, from your enterprise network messes up a controller. That's what you want to prepare against. And that is, in order to do this, you don't need those sophisticated intrusion detection systems. And you also don't need all those SOC analysts that analyze their ass off in trying to understand what this interaction with that process variable for a device that they don't even see all the details for. They only see an IP address. Well, could that be something fishy? So they engineer their ass off only to find out a couple of days later, that was a legitimate interaction. So compress your effort and maximize the results. And that is what Dataflow gives you instead of intrusion detection solutions that do the deep packet inspection stuff. See you next week, same place, same time.